Hopefully our last part here for Trig, the very first lesson, the prerequisite P.2 lesson here. Hopefully it's the last one, but let's continue here with properties of quotients. This is where we left off from before. So let's see here. Alright, so in the fifth one, a over b plus c over d. This is basically saying that the bases aren't the same, and if the bases aren't the same, you're going to need to find a common denominator. So common denominator would be you multiply this side by d and this side by b, which is what we did. Notice how a has a d beside it and c has a b beside it. So 2/5 plus 3 over 6, I find a common denominator. I multiply this side by a 6 and a 6, that's why it's 2 times 6. I multiply this side by a 5 and a 5, so 3 times 5 is 15. So 12 and 15 on top, 27 and a 30 on the bottom. When you multiply though with fractions, you just multiply straight across, which is what that's saying here. And I believe that is supposed to be a D. Okay, so we fix that up there. It should be AC over BD. Just multiply straight across. So 3 times 4 and 7 times 6. So 3 times 4 is 12. 7 times 6 is 42. And we can reduce that to 2 over 7. Okay, when dividing, it's the same as multiplying by the reciprocal. So notice here, I have A over B and A over B. So division and multiplication, all I did was flip that, so now it's a D over C. So whenever you're dividing fractions, it's like saying multiply by the reciprocal of the second one. And now you can just go straight across and multiply. So 8 over 10 and 4 over 5, I just flip the 4 over 5, so I get 8 over 10 times 5 over 4, and now I can just multiply straight across. Get 40 over 40, which equals 1.
Good evening. I'm Ron Burgundy, and this is what's happening in your world tonight.
So a number line. I'm just putting in some numbers so you can see where things are. That's really all this is for. Notice that's the same, just going down in order here. So 1, I know it's not evenly spaced, but it's just so you can see that the square root of 2 does fall in between 1 and 2, so that you can get the idea that negative 1.5 falls in between negative 2 and negative 1. I understand it's not evenly spaced the whole way, but it's just something to keep in mind. 2.33 is a decimal. 3.1415926535. Okay, they're all in between there, just so you can get a rough idea that everything is in between there. These types of fractions are the hardest to realize, that they are in between certain numbers. 23 over 5 is in between 4 and 5. Just something to keep in mind, that sometimes those fractions are a little tougher to tell.
And then
All right.
traveled to the 7 levels of the candy cane forest, past the sea of swirly, twirly gumdrops, and then I walked through the Lincoln Tunnel.
Laws of signs. If A and B have the same sign, then A times B and A over B are positive. Doesn't matter if they're both negative or both positive. They'll both be positive. If A and B have opposite signs, then they're both going to be negative. Whether you divide them or multiply them, they'll both be negative.
Time to go home now, little doggies. Nothing for you in this truck, no food.
Alright, if x is greater than 0 and y is less than 0, determine those signs right there. So what this is saying is x is greater than 0 and y is less than 0. Well, notice how that's why the y's are negative and the x's are positive, because the x's will be positive and the y's will be negative. So here's what I'm going to do. I'm just going to do an example. Let's say that x is 3. That's greater than 0, right? And let's make y negative 5. That's less than 0. So I'm going to plug it in. So 3 goes there. Negative 5, because y is less than 0. So negative 5. Up here, negative 5, and a 3 on the bottom, because that's positive. Well, what did we just say? The rules for negative are positive. So that's a 5, and that's a 5. So really what I did here was, here's the 3 over 5 that we would get, and I multiplied the bases by 3 because I'm trying to find a common denominator. So really, this is 3 over 5 and 5 over 3. And then I'm multiplying to get a common denominator of 3 and 5 on each of those sides. That's why this is written this way now. So I'm getting 9 over 15 and 25 over 15, which gives me 34 over 15. Okay, so looking back here, the reason why it's negative 5 is because up here I'm replacing y, not replacing the whole thing. I'm just replacing y. So it's negative 5, negative 5 up there, which gives me 3 over positive 5 and 5 over positive 3. And then the reason I'm multiplying here is to find common denominators. And if this base is a 5, then I'm going to multiply it by a 3 to make sure I get a 3 there. And if this base is 3, that's why I'm multiplying it by 5. And then we add straight across with the fractions because now we have the same base to get 34 over 15. So the sign is positive. So this example helped us figure out that, well, when I multiply, or when I add those together, I will get a positive number.
What are you looking at, butthead?
So absolute value. Absolute value is you're going to get a positive number. So, for example, if a is greater than 0, so like the first one here, if a is greater than or equal to 0, then you'll get whatever that is. So if it was like 5, I'd get 5. The absolute value of 5 is 5. The absolute value of 10 is 10. But down here, if it's less than 0, it's negative. So the absolute value of like negative 4, okay, you're actually going to still get a positive answer there. So for example 4, the absolute value of 3 is 3. That's simple. You're always going to get a positive answer out. So the absolute value of negative 4 is 4. The absolute value of negative 8, 8. The absolute value of positive 14 is positive 14. So this is where it gets to be a little trickier. 2 minus root 2. Okay, well, here's the point. Is it going to be a positive answer or not? So you can try to use your calculator to figure out if it's going to be a positive answer or not. Okay, and 2 minus root 2 is positive, right? Root 2 is 1 point, not exact there, but it's a positive number. So 2 minus 1 point something is still going to be a positive number. So even if I rounded and said that this was like 1.7, we'll just say, or 1.3 or something like that, 2 minus 1.3 is positive. 2 minus 1.7, it's positive. The point is, this is a positive decimal smaller than 2, so you're going to get a positive answer. So 2 minus root 2 is still going to give me whatever's inside, which happens to be positive. Because right there it is, root 2 equals 1.4141. So 2 minus 1.4141 is 0.5859, and that is positive. So that's why instead of me giving you a decimal answer up here, I just rewrote exactly what I had in the middle.
So why don't you make like a...
So this one, for example, all right, the absolute value of x squared plus 4 is greater than 0. So the real question is, why is the answer x squared plus 4? Well, let me explain. What happens when you square a number? Any number. All right. If I put in a negative 3 there, what's negative 3 squared? Positive 9. If I put in a 4, what's 4 squared? Positive 16. The point we're getting at is, no matter what you put in for x, this is always going to be positive plus a positive. So a positive plus a positive, the answer is always going to be positive. So the point I'm getting at is the absolute value of this number is always going to be positive. So since something squared is positive, a positive plus a positive is going to be a positive. That's basically what I'm getting at there. In this one, x minus 1, when x is less than 1. So I'm saying I could plug in a 0, a negative 1, a negative 2. So try it. If I plug in a 0, I get 0 minus 1, which is negative. If I plug in a negative 1, negative 1 minus 1 is negative 2. If I plug in negative 100, so the point that we're getting at is any number I plug in that fits into this little formula right here will always be negative. So like I said here, 0 minus 1, if I plug that in, that'll be negative 1. If I plugged in a negative 1, if I plugged in a negative 100,000, all of them are going to be negative. So what we need to do to find our answer is we would rewrite the inside as a negative. So I took the inside and I put a negative right on the outside of it. Negative times all that junk. So I get negative x plus 1. So if your answer is going to be negative, you need to rewrite it as a negative. So whatever your answer is, that's why I put a negative on the outside of that. And there's the answer.
Kids, we're going to have to eat this cake by ourselves. Your Uncle Joey didn't make parole again.
Okay, so when we come back here, we will talk about distances between 2 points.